The final concept in Einstein's special theory of relativity that we're going to discuss is that lengths contract in the distance, in the direction of the motion, or that space contracts. Either way, you hear it said either way. So the way to show that this actually happens is we usually use the meter stick analogy. Suppose that you have a meter stick. I know this is a pen, but pretend like we know the length of this object. And the reason we usually use a meter stick is because the length is well known. We're gonna say that the faster it goes, to someone observing that meter stick as it passes, it's that meter stick's going to appear a little bit shorter. And so here's the person that's sitting right here, and here comes the meter stick, and they want to measure it. Well, the way we're going to measure it in our analogy, in our little example here, is with stopwatches. So we're going to take the time when the tip of the meter stick passes a point that's directly in front of me, and then we're going to take the time again when the back end of that meter stick passes a point in front of me. If I know the speed of the meter stick, you can use distance equals rate times time, and you can calculate how long the meter stick actually was. You can see the issue with this already, and that is we're using clocks, and we just said in the last section that clocks have some issues with them when it comes to motion, right? They slow down. And that's exactly what's happening, in fact, and that's what leads to the effect. From the meter stick's perspective, it's not moving past me, I am moving past it. And so, with respect to it, my clock is running a little slow. Slow clocks read less time. And so, the amount of time that I'm going to read for this meter stick is going to be smaller than the amount of time that I would read if I were at rest. And hence, I'm going to get a shorter distance for that meter stick. So you can see that length contraction and time dilation, those are the fancy words for time slows down the faster you go, lengths get shorter the faster you go. Length contraction and time dilation are two different sides of the same coin in relativity. They're reciprocal effects. Depending on which way you're viewing the phenomenon, you'll either see time dilation or you'll see length contraction.